everybody to the InfoQ podcast. My name is Roland Meertens and today I am interviewing Anderson Parra and Vitor Pellegrino. Anderson is a senior software engineer at SeatGeek and Vitor is the director of engineering at SeatGeek. I am speaking to them in person at the venue of QCon London. And in this podcast, we are discussing how SeatGeek is handling high-demand ticket sales and how they deal with spikes in the traffic. The day before we recorded the podcast, they discussed this topic in their presentation at QCon. And in this podcast, we are going to dive a bit deeper into some of the future ideas they want to work on. At the moment of recording, you can still register for QCon Plus if you want to see their talk live, and you can ask them any questions yourself. Now, onto the podcast. Welcome, Vitor and Ender, to the InfoQ podcast. We are here at QCon London. We just had a lunch, and how's your day so far?
Well, it's been great. So second day of the event, we had amazing talks. Yeah, I mean, it's been very good to be back in person in a live event. So yeah, lots of good energy so far.
Yeah, good to hear. You actually had your talk yesterday. Can you maybe tell a bit about who are you guys actually? Where are you working?
Yeah, so my name is Vitor Pellegrino. I run the cloud platform teams at SeatGeek. So we were responsible for all the components of the platform that other SeatGeek engineers use. So think about like compute, storage, networking, but also capabilities for the whole company, such as like SRE, instant response.
I'm Ender. I'm working as a senior software engineer at SeatGeek. I'm working the app platform team, and we're responsible to build the virtual waiting room. That was the topic of our presentation yesterday. Today is less stressful. Enjoy the rest of the conference, then yeah, it was good. We received good feedbacks then.
Yeah, so what are you guys currently working on? Like, what was your talk about? What are the challenges you're having?
Yeah, I mean, at SeatGeek, we handle very large on sales. So for the folks that do not know that space, so on sales are typically large events that they are also met with like significant market push. They usually happen at specific times. I mean, you can imagine like you want to attend like a soccer match from Liverpool and then you want to buy tickets for it. So maybe like the club is going to announce, okay, at 2 p.m. Wednesday, everybody is going to be able to finally buy their tickets. So there is a lot of demand. And that's part of like an everyday thing for us. So we have to build systems that are capable of handling that. And our talk was defining that problem space, talking a little bit more about how we reason about that problem when we are actually developing systems. So as I said, like that's an everyday thing for us. So our systems must also handle that as if it were like an everyday thing for them as well. And then we dive deeper like in what Andrew was talking about, like the room. That's how we call like virtual waiting room. Yeah, we also like to give like funny names for stuff, I guess. And I think like that is a core component that allows us to handle those situations, those on-sale situations.
Yeah, so maybe to summarize it, if I want to buy a ticket for an event, I go to your webpage. Of course, thousands or 10,000s of people do this all at the same time. Yeah. So I assume that the normal auto-scaling techniques are not applying here anymore. Yeah. So everyone enters a virtual waiting room. And I think what you especially mentioned really nicely in your talk was how do you kind of prioritize people? I think you were talking about fairness, right? Yes. Maybe explain that for a bit.
As you mentioned, it was well described by Vitor yesterday. Sometimes the auto scale doesn't help when we receive the high traffic in 1 second, Then you try to avoid errors. Then the idea that we need a queue to control the traffic to the infrastructure. But we are selling tickets, and the idea that everybody should have the opportunity to purchase tickets as far as possible. The way that you guarantee that you manage the state of the queue, then everybody, when getting settled in the queue, is associated with a timestamp, and based on this timestamp, you can sort, and then you are draining the queue in first in, first out approach. Then the idea that who arrived earlier should have the opportunity to try to purchase earlier.
Yeah, so it's really all about kind of replicating the experience of buying something in real life, and the person who comes at the first gets the tickets.
Exactly. Yeah, but I mean, the queues are bad in the real world and the virtual world as well, right? We know that, and we're trying to drain the queue as fast as possible. Try to make the on sale going as fast as possible, right? That's the good on sale, when people can purchase the tickets earlier. Then there is no bad experience with some errors, and the idea that we're controlling the traffic to avoid errors for the user.
Yeah, I think you also mentioned a bit like what's actually the limiting factor? Why can't everyone buy the ticket at the same moment?
Yeah, we're talking about something that actually exists in the real world. Like there are seats and there is a lot of demand for the same seats. So there is a physical limitation there. So imagine that we have a specific seat premium or not, doesn't really matter, but one specific seat that you have like 10 people trying to buy at the same time. Yeah. And how do you tie break, right? So how do you actually resolve? Like, was a person that first saw the seat has a priority? Was a person that actually submitted the first successful card payment for it, like, or the first one to reserve? So these are the kind of things that we need to design for. To your point, like, I mean, that's why we cannot just allow everybody to buy at the same time.
Yeah, so basically everybody tries to go for that front row seat, but of course there's a limited amount of front row seats.
Yeah.
For the business model, when the sale starts, the race condition starts as well, right? Then there are a lot of people trying to purchase sometimes the same seat. Then the way that we're operating, we can reserve the seat and we have a time to finish the purchase. But a lot of bad things could happen in that purchase phase. Credit card could be denied, or we realize that's too expensive that you give up. Then the seat becomes available again. Then another user has the opportunity to try to purchase this ticket, right? Then you try to control the traffic as well. You can try to maximize the chance for people to get a ticket, Then you need time to finish the purchase sometimes. Then the queue helps in the business side as well.
And kind of how many people are we talking about? What's the scale of the system? I think you had some graphs where you show the normal usage of your site versus those kind of thundering herd events.
Yeah. Usually our flat line is relatively stable, but it can go like several orders of magnitude, like 2 or 3 or sometimes 4, depending on the event. So, yeah, I mean, you can expect that for a large stadium, let's say, imagine your largest stadium as for an American football club or something, like you're talking about several tens of thousands of users, and then you are going to have like perhaps hundreds of people interested to buy each seat. So that is like a magnitude we're talking about.
Yeah, so you really have massive peaks.
And I think like one important thing, and that was like something that I tried to stress, and was one of the key points for us proposing this talk in the first place, is it isn't enough to just say, okay, I'm going to always sustain that kind of load at all times. You need to be able to also reduce and shrink your infrastructure when you do not have those events. So yeah, I mean, we could be always prepared to handle that kind of load, but that wouldn't be economical. It wouldn't make sense for us as a business.
Yeah, we try to predict when there is on sale, try to predict the traffic for that on sale. Then the good part to have the queue, we're collecting metrics for the on sales. And then we are using those metrics to predict the next seasons, to see, okay, I have the seasons of the on sales, then I collect metrics for that. And how is going to be the next one, How can I use the audience that I have seen trying to purchase the tickets to predict the next event in terms of traffic?
And is it something which you do manually right now? Do you say, okay, these teams are really the top league teams, so they tend to sell out, and these teams are like the lower level teams, so they have a bit more time? Or is this something you're also trying to learn from the data?
A lot of that is already automated. It's still like a next step for us to increase the amount of automation that we have. We have close relationship with our customers. So one thing that I forgot to mention in the beginning, like SeatGeek, I would say that most of our listeners are going to be following the consumer category, which means like somebody trying to attend an event. But we also design for the folks offering those events in the same place. So these are our customers as well. So the enterprise customers, as we call them. So we work in conjunction with them. We help them with like whenever they're about to do one of these large on sales, like we're typically in close contact with them. So we do have systems that understand when an on sale is about to happen, but we're increasing even more the amount of automation from that, starting point.
Yeah. So in terms of scaling, I think you guys were mentioning the stateful versus stateless architectures. Maybe you can talk a bit about that. Like what kind of decisions are you making? What kind of options do you have?
Well, that was the main topic that when we started to build our virtual waiting room is how we are going to control the traffic in terms of to reduce the latency, right? So the best way, ideally, in the ideal world, we could run in the edge part. Then, for example, we are using Fastly as our CDN provider. Then we can try to create a mechanism to control the traffic on the CDN. But on that environment, it's completely stateless. Well, I'm going to talk about that. Then you have this idea that it's stateless. And then if it's stateless, you can have rate limit, but you cannot control the order. And as I mentioned, the order matters for, right? You can like to create a fair approach. Then we need to manage the state of the queue. Then you need a stateful model. Then we have traditional backends. When you store, you're controlling the state of the queue in our database or using DynamoDB as our primary data store. But also we have a hybrid mode that we have part of our logic running in the CDN And when I said that's completely stateless environment, then that's the chain that the CDNs are making right now. So there's some small data stores on the CDN. We're taking advantage of that. Fastly offers for us Edge Dictionary is a simple key value store that we are using as our primary cache. Then we have the problem to sync two data stores, right? We have that data store running in the CDN and also with our primary data store on the back end. Then we have all the mechanisms to keep those data stores synced. Then we can try to take the advantage when it's possible to run the logic on the CDN to remove the latency. And then if you don't need to send a request to the backend, then we avoid that and the CDN takes that part.
So I think that's a good summary of your talk, or most of the things you taught in your talk. And so if people are listening, it will be online on InfoQ, so you can rewatch it. But I think you also, what I may want to do is go a bit deeper into some of the suggestions you had for the future, right? So like, what are the next steps with your system? Or what are the things you're thinking about scaling it even better or even further?
Yeah, that's something that we're spending a lot of time. And as I mentioned in the call as well, it's a topic we're actively working on. We don't have all the answers yet. But one thing that is important for us is really having the systems understanding which mode they are operating. So we have a lot of metrics. We made a lot of investments in observability. So, every system they provide logging, extensive logging, tracing, metrics, like I think a lot of our listeners, they probably are used to. But we aren't able yet to say, okay, I want to see how my system behaved outside of an on-sale versus how it behaved during an on-sale. Like, we can infer that, like we can see the graph is pretty obvious, but I would like to be able to say, okay, that was the latency of this endpoint when we were under an on-sale. Like, oh, that's the amount of requests that happens throughout my entire system for this particular on-sale, not only in the front end, but actually all the stuff that happened. And I like to be able to categorize each one of the requests, say that's an on-sale request.
Yeah, I can imagine that in this case, if your P99 is kind of irrelevant because it's really about like 99% of the time you're not having it on sale.
Exactly, yeah. A problem that we have, going even further, like we talk a lot about SLOs, right? It's a very common thing that I see. Like for us, SLOs are very difficult to be used as we normally see in the industry, precisely for that. Like if I have an error budget of, for the sake of the argument, 100 errors. If I have 100 errors outside of an on-sale, that's not a big deal. But if I have 2 during an on-sale, it might be disruptive enough. So how can I think about SLOs for a specific time of the day, right? So I'm not interested to know how many errors I had in the last 30 days. I'm far more interested to know how many errors I had in on-sales in the past, 30 days. Right?
Yeah, I think especially for users, it's always when you want to buy those tickets, you want to buy it effortless. And I think I had cases where you went from place 10,000 in the queue to place 300,000. You're like, what's going on?
Yeah.
The on-sale is the critical window for us. What Vitor said makes totally sense in terms of if you have the critical window when everybody was looking to you to try to do an action in the product to purchase the tickets, that's the moment that you need to avoid error, that you need to care more about our system, right? And then you need to know that the on-sale is there for the size of the audience, for what's the impact of the error, how many people are going to be affected. And with all that information, you can try to react for that. And you have process, you are training people that they can try to handle errors better. Because it's really hard to say that it is completely error-free. Then it's common that you can have errors in the applications. But I think the most important thing is if you have a error, how can you handle that? And what's the lessons and learning that you can have from the error to try to prevent? Because you are always in that process, right? In the continuous improvement. Then you can try, okay, I've seen an error, I prevent that. Then what's the next one?
Yeah, so how does it work? Do you log a lot of data also during the on sale, like when you actually putting tickets on sale? Or I can also imagine that at some point you want the most bare bone structure as possible to actually handle everything, right?
Yeah, we log, and that's the whole point. Like right now we make no distinction whether we are in either mode. And that's something that we would like to change in the future. Like, we're going to still log everything, but we like to categorize. Maybe a way to think is just like, okay, well, I want to place things into different logical buckets, and I want to be able to reason about either bucket like differently. So another thing that's important for us It's understanding our non-functional trade-offs. So I think like if I'm browsing right now, like if I want to see what's happening in London for tonight, I actually would care much more about like the site feeling very snappy. I'm getting access to what I need. Like latency is very important to me. But if I'm in the middle of an on sale and I'm already in that stressful situation, I care far more if I press the button, I actually get the ticket. I don't mind as much if I have to wait 200, 300 milliseconds, or even a second for the sake of the argument. So that's the kind of stuff that we are building that knowledge inside of our application. So I'm spending a lot of time thinking about that. Okay, how do we get teams to design their systems with that in mind? So how can I perhaps pass that information using, a notification system that each microservice is able to understand?
Yeah, so your non-functionals are really indeed changing then over, like between these different phases.
I think the key point is automation, right? That's something that we're trying to make our systems a little bit more sophisticated, that they can understand what mode the system is running. If it's on sale, how can you just trigger the alerts different if you have an error? How can you recover as fast as possible on that moment? Then when you are not in on sale, then it's a less stressful situation. Then you can say, okay, I have time to see what's going on and to provide a fix for that,
Yeah, so you were mentioning kind of trying to run the system at some point by robots or running everything automatically. How is it currently? Is there a lot of manual work involved into putting each ticket online, or?
When we started the virtual waiting room, you have a lot of manual work to set up protected zones and to see the paths of the events that are going to be on sale. Nowadays, everything is automatically. Then when the event is created, in terms of, okay, someone was designing an event, the stadium, how many tickets are going to be available, and say, okay, this is going to be on sale in a certain day, then the protected zone is created automatically. You have over than 2,000 protected zones running in production. It means that all the events are protected by that queuing system, and then reduce it completely, the manual work. And we are still working to reduce even more. The idea that, okay, we know that the time for the engineers are really important to do engineer things, and you try to reduce that engineers to operating systems, Yeah. And then we can automate it. You can see that, okay, if the CPU is going up, then you can take decisions like something is looking to the chart, to the graph, to the spike in the CPU, and decide to reduce, for example, the exit rate of the protected zone. If it's a manual work, you could do the automation as well, because you can try to understand what's going on with the CPU, then you can take a decision in the system. And that's the idea, that the next steps for the evolution of our own sales. You can try to reduce the number of people operating it,
Yeah, because right now a lot of people are still looking at how many people are buying tickets at the same time. So can we allow more in or less in, right?
Yeah. That's what Andrew was mentioning with the exit rate. So right now, like people have to make a decision like, okay, it seems like we're able to sustain more loads. So instead of allowing fictional numbers like 300 people every minute, let's allow now 500, 1,000. Or maybe it's going the other way around, like actually we're not able to sustain as much, so let's reduce that to avoid a bad experience to everybody that is already buying. So that's the kind of stuff that we want to allow for much more automation, so the system, they're able to adjust their thresholds automatically.
Yeah, and I think you're also thinking about like the alerting, right? How does it currently work? Do you wake people up at night to push more tickets, or?
No. Our customers define how they want to buy. So I think like the thing that wakes up engineers at night is more when things, like most companies, when they don't work as intended. But I think like in the future, we would like to adjust the priority of these alerts. Again, coming back to the overall theme about on sale or not. So right now, if people are having like any service disruption, we're going to treat that the same. But I would like to be able to say, okay, if it's an on sale, it's actually something that I can wake up fully refreshed and take a look with fresh eyes in the morning. But if that's on sale, please wake me out of, whatever I'm doing, right? So that's the kind of things we're looking to do.
I think the other thing you mentioned at some point during the talk was fraud detection, that someone could maybe very quickly buy a single ticket automatically. Is that fraud? Or someone maybe buying 100 tickets for the entire group of friends. Is that fraud? How do you handle this at the moment?
Yeah, it's a good point. That was within the topics of we need to think about these things at every on sale. So we leverage a lot of machine learning and fraud detection systems throughout the entire stack. So sometimes like people execute some actions and then post factum we realize that they could have been fraudulent. So we have systems to care for that. We use a lot of different tooling around bot protection and all of that, but it comes with the question, right? If I am trying to buy a ticket and I use, I don't know, Selenium to automate that task, like where do we draw the line? Is 10 tickets okay? Is one ticket, 100 tickets? So that is the kind of things I would say we work very closely with our customers, and then we define, okay, that's what we believe is an acceptable behavior, right?
And the queue helps.
The queue helps on that part, because the way that you guarantee controlling the traffic, then you try to identify real users and bots and remove bots from the traffic. Then you can try to guarantee that people that get into the protected zones that has the opportunity to purchase the tickets, they are real users. But it's hard. The same way that we are working to prevent, people are working also to bypass. Then, that always is that way, right?
So you also mentioned machine learning. What are some of the best features to detect if someone is a bot or not?
It's a good question. I think like we use systems that provide that almost as a kind of standalone service, right? So they analyze the usual patterns, like how fast people navigate through a web page. Just one example, right? There were a lot of signals involved.
Well, there are systems that create fingerprints in the request. Fastly helps as well to create a stamp in the request, say, okay, that's a bot or not a bot. And we don't rely on only one bucket, because as I mentioned, say, people are trying to bypass that, right? Then you have the combination to try to identify that's a bot traffic or not. Then we try to guarantee as fair as possible the user experience for real users that are trying to purchase the tickets, because that's the most important part.
At the end of the day, you want real people to sit there and not the scalpers making money off your tickets.
Exactly.
And you were mentioning Fastly as your content delivery network. So how does edge processing, how does a content delivery network work here? Because I can imagine that because the state of your database and the available tickets changes so often, you can't cache too much at the moment.
Well, the problem that if you are caching, then you need to have a way that purging the cache, right? Then we are thinking in event orchestration. Because if you cache in the CDN, then you can see the latency going down, right? But if there's a change in the event, for example, then you need to have a way to purging the cache that was made in the CDN, for example. The way that we're thinking about that, systems could react for the change through events. And then you can orchestrate, choreography the events in terms of, okay, so if something changed in the event model, then I know that I need to change the protected zone, that's the queuing system, and also I need to purge in some cache. Then, again, it's connected with the automation part, right? We like to keep our systems as smart as possible in terms of reacting for change without manual intervention, But we have heavy usage of CDN in the end. For caching is an example, and part of our virtual waiting room works there. Then we have logic to validate visitor tokens, access tokens, because in the end, the virtual waiting room is an exchanger of visitor token to access tokens. And also you need to maintain a state of the protected zones in the edge dictionary. That's the way that we can control how we're going to route the traffic. It should go to the queue, should go to the target, should go to a blocked page, and then you have that part of the logic running the CDN, and then you don't need to communicate to our backend. That's good as well in that case that you can reduce the cost that we have with our backend, right? Because we are distributing how we are executing the computing in the different layers.
Yeah, and I think you were also mentioning storing data at the edge. What are your ideas around that? Is this something you're already doing, or is this something you're planning to do?
That's something new, right? Then this edge dictionary in Fastly is something you are already using. You are taking advantage of that. We can see another companies like AWS with the CloudFront. They have the Lambda Edge, and they're using the DynaDB as the edge data store with the global tables, because edge running in different regions, then you can try to make the data available for all the regions. For us, Fastly works quite well. Then the times to replicate the data store is around 30 seconds. DynaDB is around 2 minutes. Then I know that Akamai is working in a data store as well in the edge. But in my opinion, that looks like we are going to have more logic running the edge in terms of to reduce the latency. We're not planning to completely systems on the edge, but the idea that you can have our first layer and try to avoid to fire a request to the backend when it's possible.
Yeah, this is something that I would have loved to have. I would say about 7-8 years ago when I was working for a company that had a very heavy usage of social graph. So you would have users, their followers, like people that they interact with. Like one of the things that I could see if I were to rebuild that system is actually trying to figure out how can I get some of the key users that have like huge crowds that follow them, actually store some of that information already close to the visitors, like in their edge locations. So these are the kind of maybe hinting towards like new technologies that we're excited about too. Like that's the kind of things that I think could be so useful to solve that use case, and we're investigating also, right? So storage at edge is definitely something that unlocks a lot of possibilities for us.
Thinking in the idea of the edge, I think we are in the moment that we're going to expand what's edge in the end. We have the 5G right now. Then we are going to have more device with nice connection where you can sync with some backend systems. Then the edge will not be only the CDN, right? The edge will be the gateway that was in the stadium that we need to open when we scan a ticket. Then you validate that ticket is valid and open the gate for that person because it's allowed to get in, Then I think going for that direction, that the edge will be everywhere. The idea for the Internet of Things is going on, right? Then finally we're going to have the problem with the connection is going to be figured out. Then we're going to have massive data, and you can try to think in how can you just improve our business, because we will have the opportunity to run software connected everywhere.
Yeah, and especially for what you said with the Dixon Stadium, what you're basically proposing is that maybe the database is at the stadium, so that even if there would be an outage outside of the stadium, you can still keep running.
Or imagine that you have the database in the gateway. Like you have a ticket and you need to go to the gate 7. And imagine for that gate 7, you have all the tickets available to get in on that one. I mean, if the gate is working, then we don't care if there's an outage. But what's the problem with that? You need to sync, right? Yeah. Then how can you sync for that event? Then if you can sync in the right moment, then you allow people to get in fast.
Yeah, and of course you don't want people to check into 2 gates at exactly the same time.
Yeah. And also like reporting that customers do and all of that. I think the main thing that kind of technology unlocks, and again, hinting towards what we could be doing, like we don't only do ticketing. That is, I would say, our bread and butter, but we also help customers, enterprise customers I'm talking about here, like manage their food stands, like manage like their convenience stores inside a stadium, right? So we can see expanding the devices to actually where the work is happening, right? So closer to the users, like visiting a stadium. So that in-stadium experience is also important for us.
And maybe as a last thing, you were mentioning the elasticity at all the layers of your infrastructure. Like, what are your thoughts on that? What's the future of that?
I think that's something we're working on right now. Our architecture, as any other company, we have things that we built in a different time. And I don't think we're able to grow all the systems in a lockstep. So I would like to be able to get to a point where, let's say there's an on sale, like while users are in a queue, perhaps you can add more database computing power, like, or increase, I don't know, even storage. I don't know, I'm making up an example here, but I can take the idea about auto scaling throughout all the layers of my architecture. Like perhaps I add different components as I need, activate other vendors to add extra redundancy. So sometimes like people focus only on the compute part, and sometimes only from one component, and then forget to also scale like the downstream components of it. And for us, that adds tremendously the amount of time that people are waiting for all the auto-scaling components to kick in. So the whole flexibility in all layers, like we would like to be able to say, okay, the same way that people nowadays do to increase the amount of processing to, let's say there's a backlog in a Kafka infrastructure or like a RabbitMQ queue, I don't know, there you add more consumers. Like we would like to reason the same way, like, oh, we have more people in the queue, therefore I want to scale all the vertical that is serving that on sale at the same time. So everything is ready, and then we can then tie back to what we talked about, like increase the amount of people that we allow in, because now we have more capacity, right? Waiting to have, okay, first my compute restart increase, then my second service and so on. That is too long for us.
Yeah, I can also imagine that it's a bit hard to, like the front end is maybe easiest to scale, but the database will be way harder, right?
Yeah.
It's hard. And that's the reason that we're monitoring everything. We're trying to avoid blind spots. Then you can use those metrics to identify bottlenecks, and sometimes the bottleneck is on the database. It means that you need to go to the whiteboard again and rethinking the solution and provide a different one that can support the traffic. And that's a constant improvement, right? I mean, there is no right answer. What works today, maybe tomorrow with a different traffic is not going to work. Then for our side, that we always pay attention to the details. You have dashboards, and we know when something is going bad. And when something is going bad, we're refactoring to support what's going on.
Yeah, the database part is just an example. Like I think like what we know is a little bit hard to change that particular layer in any architecture. But I think we can do a lot of progress already just by increasing and scaling the dependencies like closer. Like for instance, if I have like a backend for front end, which lives closer to my front end that talks to 10 different services. Like if I can scale all of that at the same time, looking at the same amount of queue, like perhaps I'm going to be able to increase the amount of people that I can let in at once in a on sale. And most importantly, like once the on sale is over, I'm able to scale all of that back down because our traffic follows that kind of like movement, and we would like to keep the efficiency of our infrastructure as well.
Yeah, like in this case, vertical scaling is easy, but scaling to the right vertical size is the problem. Yes. All right. Any other things you wanted to talk about?
Yeah, I mean, like we're very happy to be here. Maybe is something that, I don't know, just to leave the listeners, like if they want to hear more about any of that, we're open to have that kind of discussion. I think like a lot of that is something that we're still thinking on, like we don't claim to have all the answers, but something we're very excited, like, and it's great to be here in an event like this, lots of energy. Like I've been spending like a lot of time in the breakout rooms and, you know, like between talks, talking to people. And then I'm just like, I cannot wait to come back and then actually get a lot of these things in practice.
Yeah, you can definitely talk to a lot of people who are struggling with the same problems or have maybe already solved it.
Yeah, and I also like to add that in the SeatGeek we have great problems, then we're looking for engineers, then yeah, if you like to work in that kind of challenge as well, we're more than welcome that you can talk about it.
Yeah, then thank you very much for being here. I hope you enjoy the rest of the conference and see you in breakout rooms talking about scalability problems.
I appreciate it. See you.
So that was the interview with Anderson and Vitor. I really hope you enjoyed this in-person interview recorded at QCon London. And thank you very much for listening to the InfoQ podcast.